Hello and welcome to PreCalc. Today is Tuesday, September 15th, and our topic for the day is solving cubic radicals. So we're solving things that have cube roots. Cubic means third power, radical means square root. Okay, before we dive into our first problem, we're going to talk about a key difference between squaring a number and cubing a number. So if I square a number, 3 squared, I get 9. That's because 3 times 3 equals 9. Now, if I square negative 3, I still get positive 9, because negative 3 times negative 3 is positive 9. So, in summary, two ways to get positive 9. We can square positive 3, or we could square negative 3. Now, if I cube 3, I get 27. That comes times 3 times 3. Okie dokie. But what happens if I cube negative 3? Negative 3 cubed is negative 3 times negative 3 times negative 3. Let's work this out. Negative 3 times negative 3, positive 9. And then I still got 1 negative 3. 9 times negative 3, negative 27. So, negative 3 cubed is negative 27, and positive 3 cubed is positive 27. So, there's only one way to get the number that you want when you're cubing. For it to be positive 27, it has to be positive 3. It can't be negative 3. Now, for this reason, we do not have to plug in and check our answers on cubics. There can only be one right answer. But you can see here, when we square things, you might get a false answer. Doesn't happen on cubics. We don't need to check for an extraneous solution on these problems. Okay, just two examples today. Let's dive into our first one. You should definitely pause here and write the problem. Pause whenever you need, though. Okay, much like how if I square a square root, it cancels. If I square if I cube a cube root, it cancels. So I need to square both sides here. I said square, I meant cube. We're going to cube both sides. These threes cancel. So I'm just left with what's on the inside, which is my 2x minus 5 equals 3 cubed. 3 cubed is 27. And now I'm just solving for x. Add the 5. 2x equals 32. Divide the 2. And x is 16. Only one answer. No need to check. Great. Let's look at our second and final example. We're going to call this example 2. And this should be a cube root here. So make sure that's a cube root. Okay, a little bit different this time. We see a plus 2 off to the side. We need to make sure to always isolate the radical first. Which means we need to get this guy all by himself first. So we need to make sure to isolate the radical first. Let's break down this phrase. Isolate means get by itself. Radical means square root, cube root, any kind of root. So isolate the radical, get the square root by itself. Okay? How can I start doing that? Well, I can take away this 2, minus 2. 2x plus 4 is all still here. 6 minus 2 is 4. Great. A little extra first step, but no big deal. We've got the radical by itself. I'm going to cube both sides. On my left-hand side, I'm just going to be left with whatever's inside, which is 2x plus 4. I'm going to show us 4 cubed off to the side here. 4 times 4 times 4. 16 times 4. 64. So all this equals 64. Solving for x, take away 4. 2x equals 60. Divide the 2. X is 30. And that's it. No need to check the answer because it's a cube root. Last thing, guys, is you might get some strange looking, kind of like ugly fractions as answers on these type of problems. By no means does that mean you're wrong. Both these examples worked out nice and neat, but sometimes you might get a messier fraction, and that's totally okay. All right, that's everything for today, guys. Thanks.